So today we'll take and add vectors in polar form and then move to doing some applications of vectors. You'll notice in this problem that I have a vector of radius 3 and angle of 20 added to a vector of radius 5 and angle of 70, and I've done this to scale here. Now when we added in rectangular form, you'd add the first components and then the second components and get the answer. Well, obviously we know that's not the case here, because if I add 70 and 20, we get a total of 90 degrees, which certainly isn't this picture. And when I just measure the length of this, or the total radius, since I've done it to scale, I should get 8, and I don't. So how does this work then? Basically, we're going to take these polar forms, convert them to rectangular, add and subtract just like we did rectangular vectors, and then convert back to polar. So let's go ahead and do that. We know to convert, we go r cosine theta, so 3 cosine 20 to get my x component, and my y component is 3 sine 20. And then likewise 5 cosine 70 and 5 sine 70. These will all be in rectangular form now. When I add the x components, I get a total of 4.52. And then when I add the y components, I get a total of 5.72. Now a reminder, this is an x and a y component. I need to go back to r and theta. So going back to r and theta, I know I have x squared plus y squared is equal to r squared. So if I take the two values, square them, and square rooted, I'll get my r. Then if I take my inverse tangent of the y over the x, I'm going to get my theta value. And in this case, we end up with an r value of roughly 7.29 and an angle of roughly 51.68 degrees. And that's all there is to it. Now we'll move into doing some application problems. So in this case, we've got two forces being added, one at 10 units, or 10 pounds in this case, one at 20 pounds, and they give us the corresponding angles in the picture. And they're asking us to find the resultant force. So remember, the resultant force is basically taking and tip to tail and putting on that resultant here. So again, we're going to add two vectors in polar form. So I have 10, 45 added to 20 and 150. And in just a general drawing of this, we see that our solution should be somewhere in the second quadrant, probably. All right, so if I'm going to go ahead and do that, I have to first convert into rectangular. So 10 cosine 45, 10 sine 45, 20 cosine 150, 20 sine 150. And then we take and add those up on our calculator. We end up with approximately negative 10.25 and 17.07. Again, that's an x and a y. Going to take and find the square root of negative 10.25 squared and 17.07 squared, along with the inverse tangent of 17.07 over negative 10.25. And we'll end up with 19.91-ish, right around there, and negative 59.02 degrees. Now here's the issue right here. We notice when we've taken and add these just by a visual, it's somewhere in the second quadrant, and this negative 59.02 is not in the second quadrant. So basically what we need to do is we need to take and add 180 degrees to that in order to get it where it should be. So we have 19.91, and when you add 180 degrees, you get about 120.98 degrees. So in this problem, it's kind of a real-life application. You've got a person who's trying to get to the other side of the river by taking off in a boat at 10 miles an hour, and you've got a river flowing to the east at 5 miles an hour, and you want to end up on the other side. So in order to do this, basically you need to take off at an angle so that when the current pushes you this way, your resultant will be straight across. We know this is 5. We know this is 10. But we don't know the angle that we have to leave at. All right. Now we also know a couple other things. Well, let's just do something real quick. Let's say the current has a vector. And that current's vector is 0 degrees and 5. We know we have some unknown angle for the boat. And let's just call this a question mark. But we know that it has a magnitude of 10. And then in the end, we know that we have some unknown resultant, and we do know that we have an angle of 90 degrees. Like so. And this is all in degree mode or in polar form. If I were to convert all those, I'd have the following. We'd have 5 and 0 again. We'd have 10 cosine some theta value and 10 sine some theta value. And then if I know I have a vertical of 90 degrees at the end, I know my x value is going to be 0 and my y value is unknown. So notice that in this column right here, I have an equation that I can write of 5 plus 10 cosine theta equals 0, which will allow me to find theta, which is what I'm trying to do in the problem. So when I go through and do this, I'll have negative 1/2 is equal to the cosine of theta. So theta is going to equal 120 degrees. Whoops. 120 degrees, and that would be from the 0 position. This angle here would be, if you want to call it, 60 degrees into current. Either way. Here's a very similar problem. It shows a large boat being towed by 2 tugboats. One tugboat is pulling at 30 degrees, the other is unknown. We have a larger tugboat that is pulling at 4,000 pounds and a smaller tugboat that's pulling at 3,200. And we want the large boat to actually be going in a straight line. So this is similar to the last problem, but we know a little bit more. Let's go large and small for the tugboats. And the result will be here. Now I'm going to do all this in rectangular form, so I'll convert everything that I can. We know our resultant, if you will be at some x value, which I don't know, but we know will be at 0 degrees. Now we know that our large boat is pulling up this direction, so it's going to be 4,000 cosine theta and 4,000 sine theta. We know our smaller boat is pulling at 3,200, and we know our angle, it's 30 degrees, but notice what quadrant it's in. It's in the fourth quadrant, so I'm going to say the cosine of negative 30 degrees. And then 3200 sine negative 30 degrees. And that's going to equal 0. Now, in this case, this column here, put in another color, this column gives me enough information to be able to write an equation. I have 4,000 sine theta plus 3,200 sine of negative 30 degrees is equal to 0. So in that case, what I can do is basically just take and add all this stuff up. I've got 4,000 sine theta equals sine of 30 we know is a half, but it's negative in this case because it's negative 30. So that makes this 1600 of the negative type. I bring that over, it's positive 1600. So we'll just take and divide and get sine of theta is equal to 16 over 40, which is about 2/5. And then theta is equal to the inverse sine of 2/5. And theta will equal about 23.6 degrees, which is actually the answer that was given to us right here. So in this next problem, what's happening is we have a TV being hung, and it's going to be hung by two support cables that are equally placed on either side. So let's draw those in like so. And I find it always good to take a picture and then create a vector drawing from it. So here's one cable, here's another cable, and then here's the TV force, like so. Now, the cable forces are unknown. I'm going to call these X. And the force on the TV is negative 800. And let's call this cable 1 and cable 2. Now, in order for that TV to hang in place, we have to have a resultant force of the three forces acting in this case of 0. It's called static equilibrium. So, cable 1 plus cable 2 plus the TV has to equal a resultant. So we're adding three vectors in this case. Now, one thing we know is this is 100 between these two cables, and if we split that, that'll be 50 on either side because it said it's hung equally. Therefore, these two angles on the other side are 40. So if I'm going to make this polar look go to rectangular, I'm going to take unknown radius times the cosine of 40, and that unknown radius times the sine of 40, added to that same unknown radius because it said it's equally supported, cosine. Now notice the angle, I'm going to put 140, and that same unknown radius times the sine of 140, and then the TV, because it's hanging straight down, there's no horizontal force in the rectangular form, just a vertical force of negative 800. And then by static equilibrium, these both have to equal 0. So now I'll set up an equation, and I'll just say, let's do it this way, x sine 40 plus x sine 140 minus 800 is equal to 0. Therefore, I have 800 equaling, watch what I'll do, x, factor that out, sine 40 plus sine 140. Divide that to the other side. And we end up with the force of roughly 622 pounds I'll go 0.29. And then our problem is going to be done. That's all we've got. We'll talk to you next time.